Now the second problem. We have two balls, ball A and ball B. Now this is a problem based on collision. Now here, these two balls are identical, which means their mass is the same. So they are both identical. Now, what we can assume is that they're going to go this way and they're going to collide head-on. That is, it's a head-on collision between the two balls. And we're going to assume that the ball A, after collision, it rebounds. Hitting the ball B, it rebounds at a speed VA is equal to 1.5 meter per second. And the ball B, after hitting A, it rebounds with the speed 2.5 meter per second. And the mass of each ball is given by 4 kilograms. So first, what we can do is that we are going to calculate momentum of each ball before collision. So momentum of each ball before collision. So how can we do that? So we can assume that the A has 4 multiplied by V1. This is the momentum of A before collision plus momentum of B before collision is, let us assume B has a mass of 4 multiplied by V2. This is equal to momentum of A after collision, which is nothing but mass of A multiplied by velocity of A plus momentum of B after collision is, this side is after collision, this is before collision. Momentum of B after collision is given by 4 multiplied by 2.5. So here, since both the balls have the same mass, what happened when they collided with each other is that this V1 transferred to blue ball and V2 is transferred to the red ball. So they shifted their velocities after colliding with each other. So the momentum before collision for the first ball is 4 multiplied by 2.5, and momentum for the second ball is 4 multiplied by 1.5. This is the total momentum of the balls before collision. Should be 20 kilogram meter per second. So now what we can calculate is we are going to calculate momentum of each ball after the collision, that is here. Momentum of A after the collision is nothing but, it will be 6. Momentum of B after collision is nothing but, it will be, so here it is 3.5. Let us take it as 3.5. It is 14, so it should be 20. Again, total momentum after collision. And as you can see, momentum is conserved. So now we're going to measure the total kinetic energy. Total kinetic energy, and see whether the kinetic energy is conserved. So kinetic energy of the first ball is half m va squared plus half m vb squared equal to, so this is before collision. The kinetic energy after collision is half m va squared plus half m vb squared, and we know what is the velocity. So mass, half m is the common term, so m is 4, we can just cancel that as 2. And what do we get here? VA squared plus VB squared. So VA squared plus VB squared is equal to then again you will get 2 VA squared plus VB squared. Now this is the same quantities because VA and VB, they're just interchanged, but they have the same velocities and they have the same kinetic energies before and after collision. It is the truth, and that is how we can say that the kinetic energy of the two objects is conserved before and after the collision when they collide with each other. So now we can do one more problem. It's a simple one. Now in this problem we are going to take a trolley of mass 1 kilogram. So we have a trolley and its mass is m is equal to 1 kilogram, and it is moving at a velocity 2 meters per second. 2 meters per second. And it collides with the stationary trolley. Now this is, let us assume this is the trolley A, and it moves with the 2 meters per second velocity, and it collides with the trolley B. The trolley B is stationary. And its mass is 2 kilograms. The second trolley moves off at 1.2 meters per second. After collision, the second trolley, this is before collision, and after collision, the second trolley with mass 2 kilograms, it has a velocity of 1.2 meters per second. Now we have to decide in which direction the trolley A will move. Will it move in this direction or in this direction? So we are going to use conservation of momentum to find out the answer. So first we have to calculate momentum before collision. So momentum before collision of trolley A plus trolley B, which is equal to mass of trolley A is 1 kilograms multiplied by velocity of trolley is 2 meters per second plus mass of trolley B is 2 kilograms, velocity of trolley B, which is at stationary, is 0 meters per second. So we'll get 2 kilogram meter per second. That is the momentum of the system of trolleys before collision, and momentum after collision, trolley A plus trolley B. Trolley A's mass will be the same, plus its velocity we do not know, and plus the mass of the trolley B is 2 kilograms multiplied by the velocity of trolley B is 1.2 meters per second. So here we'll get VA plus 1 plus 2.4 kilogram meter per second. So now we can equate that. We know that momentum is always conserved. So these two quantities must be equal. So we can equate that. So 2 kilogram meter per second is equal to VA plus 1. Sorry, here it must be multiplication. So VA plus 2.4. So now we can subtract 2.4 from both sides. So what will we get? 2 minus 2.4 is equal to VA. So VA equal to minus 0.4 meter per second. So what does the minus sign indicate? Minus sign indicates that after collision, VA must be going in this direction with a velocity of 0.4 meter per second, and its mass will be the same, just 1 kilograms. Thank you for watching.